Let's look at another example of finding surface area. The function we're given is f of x and y equal to natural log absolute value of secant of x. And the region is all of the ordered pairs x and y such that the x coordinate is between 0 and pi over 6, the y coordinate is between 0 and tangent of x. So let's think about what the curve tangent of x looks like in the xy plane. And I know my x is going to be between 0 and pi over 6, so I know that I'm going to be just in the first quadrant. But the tangent curve should look like this. It should be an odd function, symmetric with respect to the origin, with asymptotes at x equals minus pi over 2 and x equals pi over 2. And of course, it repeats, so I get infinitely many curves just like this one, but I'm only going to draw the one. We just need one period of tangent in order to see what our region looks like, because I know that my x's stop at pi over 6. So if pi over 2 is here, x equals pi over 6 is somewhere here. So I know that I only need to draw one period of tangent in order to see the region I'll be integrating over. So it looks like if y is between 0 and tangent and x is between 0 and pi over 6, it should be that little region there. And I'm finding surface area, so I know that I'm going to be finding the square root of 1 plus my partial with respect to x whole squared. Whoops. Let's not do that. Okay, 1 plus my partial with respect to x whole squared plus my partial with respect to y whole squared. So let's find these first. My function is actually just a function of x. So I know that my partial with respect to y, my first partial, is going to be 0. Now when I look at my first partial with respect to x, I'll use the chain rule. The derivative of natural log is 1 over x, so that's going to be 1 over secant of x. I'm going to drop the absolute value because I know that between 0 and pi over 6, secant of x is positive. Then the chain rule tells me I'll have to multiply by the derivative of secant of x, which is secant x tangent x. So when I simplify, I get that the first partial with respect to x is just tangent of x. And as I said, first partial with respect to y is 0. So then this square root just becomes 1 plus tangent squared, the square root of 1 plus tangent squared, which is the square root of secant squared, which is secant of x. So now I think I'm ready to set up my integration. I'm going to integrate from 0 to pi over 6 on the x-axis. My y's will be between 0 and tangent of x. And then the square root of 1 plus the partials squared is going to be just secant of x, then dy dx. So integrating first with respect to y, I get to say this is 0 to pi over 6 and treat secant of x like a constant. So this is secant of x times y, which I'll evaluate between 0 and tangent of x. So that's 0 to pi over 6, secant of x times tangent of x, and then minus secant of x times 0, but that's 0, so let's just not write it. Secant of x tangent of x, I know, is the antiderivative, is the derivative of secant, which means the antiderivative of secant x tangent x should be secant. So when I take the antiderivative, it's secant of x, and I want to evaluate between 0 and pi over 6. So I get secant of pi over 6 minus secant of 0. And if I'm not sure off the top of my head those values for secant, I know that secant is 1 over cosine. So cosine of pi over 6 is square root of 3 over 2. That means secant of pi over 6 should be 1 over square root of 3 over 2. And cosine of 0 is 1, so it should be minus 1 over 1. And that is 2 over square root of 3 minus 1. Or if you prefer to rationalize it, 2 square root of 3 over 3 minus 1. And that should be good enough to answer the question.